Alright, in these examples, we're going to see how to use trig functions to find pieces of a right triangle that we are missing. So this triangle, for some reason, doesn't have our right angle box drawn. We're going to go ahead and draw that in. So the first thing I like to do is I like to label my hypotenuse, because that is always across from the right angle. Now, we're focusing on this angle right here, the 27, because that's what's given to us. So this side would be adjacent because it's the side that helps make that angle. This side would be opposite because it's the one I can draw the arrow to go across. So when I'm trying to decide which function to use, I have to see where I have information. I have information here on the hypotenuse, and I have an x here on the opposite. So if I have opposite and hypotenuse, I look at my reference sheet and I see which one involves opposite and hypotenuse, and it's sine. So I'm going to write down my formula. The sine of theta equals opposite over hypotenuse. This theta symbol just means angle. So I'm going to say the sine of 27 degrees is x over 12. Now this becomes a proportion, and the easiest way to do this, since we practiced with proportions in the other section, is to put a 1 on the bottom. I'm going to cross multiply. I'm going to multiply 12 times the sine of 27 is equal to 1 times x. 1x is the same thing as just saying x, so I'm going to get rid of that 1. Now I have 12 times the sine of 27. Now, in this calculator, we have to remember that this part here, I type things in the opposite order. So if I hit 12 times, then I'm going to hit 27 sine, and then equals. And I get 5.45. So 5.45 is x. Okay. I could also do 27 sine times 12. Still get the same answer. Okay. In this calculator, I'm going to do 12 times the sine of 27. This one's a little bit easier because you're typing it in exactly as you see it. Okay, our next triangle. Again, we start by labeling. This is the hypotenuse because it's across from the right angle. This triangle, they're giving us 2 angles. Okay, so I get to pick which angle I want to use. Okay, I'm going to pick this one. This side would be adjacent to this angle. Okay, this side would be opposite of this angle. I see that I have information here for hypotenuse, and I have information here for adjacent. So adjacent and hypotenuse tells me to use cosine. So I'm going to say the cosine of 69 is x over 9. Okay, so same thing we did before. We're going to put a 1 down here, and we're going to cross multiply. 9 times the cosine of 69 is equal to 1 times x, which is just x. So I can type this into my calculator. 69 cosine times 9 equals. And I get 3.23. Okay, and my other calculator, if I'm using this one, it's 9 times the cosine is 69. Same answer. Next question. We have this angle. This is definitely our hypotenuse because it's across from the right angle. If I'm focusing on this angle, this is adjacent because this side helps make the angle. And then my y is going to be my opposite. So in this problem, we have two different variables to solve for. You can pick which one you want to solve for first. Let's say I pick y. Okay, I know my adjacent and I'm trying to solve for opposite. Opposite and adjacent tell me to use tangent. So this is, oops, I switched that around. Let me write my formula again. The tangent of the angle is opposite over adjacent. So I'm going to put y on the top and I'm going to put adjacent on the bottom. So same thing we did before, we're going to cross multiply. We get 8 times the tangent of 54 is equal to 1y, which is just y. We're going to put this in our calculators. Okay, we can do 54 tangent times 8. That's one way we can enter it. Or we can do 8 times 54 tangent and then equals. Either way, we get 11.01 for y. Okay, our next one, we need to figure out x. For x, we're going to do cosine. I'm going to do this up here. I have a little bit more space. So cosine of the angle is adjacent over hypotenuse. So for this problem, we have the cosine of 54 is equal to 8 over x. Now, if I cross multiply, I'm going to get x times the cosine of 54 is equal to 8. I have to get x by itself. So in order to do that, I would divide by the cosine of 54 on both sides. These cancel out, and I get x is equal to 8 over cosine of 54. So in my calculator, it is not going to let me type this in as a fraction. I have to remember that that fraction bar means divide. So 8 divided by 54 cosine equals. So x is equal to 13.61. Okay, in my other calculator, I could do 8 divided by the cosine of 54 and get the same answer. Example 6, we have a word problem. When you have a word problem, you're going to have to draw a picture. So it says the angle of elevation from a point 62 feet away from the base of a flagpole. So let's draw a flagpole. Okay, the angle of elevation from a point 62 feet away from the base of the flagpole to the top of the flagpole. So this is 62 feet. The angle is 34. Find the height of the flagpole. Round the answer to the nearest tenth of a foot. So a flagpole, this can be a right angle. We know that if this is my angle, this is adjacent, this is hypotenuse, and this is opposite. I'm trying to find the height of the flagpole. So this is my missing piece of information. So when I look to see what I'm dealing with, I have information here. This is what I'm solving for. I don't know anything about the hypotenuse. So I want to use tangent because tangent is opposite over adjacent. And that's what I have in my picture. So the tangent of 34 is x over 62. I'm going to think about this as a proportion, and I'm going to cross multiply. 62 times the tangent of 34 is 1x. This is what I'm typing in my calculator. So 62 times 34 tangent equals. It's really important that you remember to hit that equals button at the end. So I didn't pay attention. It said nearest tenth of a foot. So it should just be 41.8.